Welcome to this Maths Made Easy video on discrete probability distributions. To start with, let's take a look at random variables. A random variable, usually denoted with a capital letter such as x, is a variable that takes different values at random with different probabilities. And the different values it can take are usually denoted with a lowercase letter such as x. So let's say x here, the capital letter x, takes the value of the score on a fair six-sided die. So in that case, this means the probability that x is equal to 1 is equal to 1 over 6. We have a 1 in 6 chance of obtaining a 1 on the die. And that would be true as well for the probability of getting a 2. So the probability that x is equal to 2. This will also be 1 over 6. And again, this would also follow for getting a 3 here. So x being equal to 3 is equal to 1 over 6. So in that case, the possible values for x here would give us lowercase values here of x. So little x is equal to 1, 2, 3, 4, 5, and finally 6 there. A discrete random variable can only take a certain number of different values. The example above is a discrete random variable, as there are only 6 possible values that x here can take. So that gives us everything we need there for random variables. Moving on now to take a look at probability distributions and probability functions. A probability distribution for a discrete random variable is a table showing all the possible values for capital X and their probabilities. And in the example that we use for the dice, this would give us here the probability of capital X being equal to little x. And here, like we just noted, each of these values, in the case of a fair die, would give 1 over 6, 1 over 6, and again all the way up to 6, giving us 6 lots of 1 over 6. Now it's important to know here the probabilities for a random variable must add to 1. So we can see that here in this example, 1 over 6 plus 1 over 6, 6 times would give us 1 there. Okay, that would give us 6 over 6, giving us 1. So we can note here probabilities for a random variable must add to 1. We can note that here as the sum for the probability of capital X being equal to little x is equal to 1 there. Okay, and we can define the probability function here, f of x, as being equal to the probability of capital X being equal to little x. And finally, the cumulative distribution function, the CDF, is a running total of the probability function, and we denote that using capital F. Okay, so this is capital F of x, and here this is again the summation y less than or equal to x of f of y, and this is equal to the probability that capital X is less than or equal to little x. Okay, so that gives us everything we need there for probability distributions and probability functions, and that concludes this Maths Made Easy video on discrete probability distributions.